Hello everyone, welcome to Edusumit. In the previous class, we discussed the topics of reflection at plane mirror. In this session, we will discuss reflection at spherical mirrors. So, what are the spherical mirrors? Okay, let us know about it. So, spherical mirrors are nothing but it is a mirror whose reflecting surface is a part of hollow sphere. That is, okay. Consider a sphere. Okay, so what does spherical mirror mean? It is nothing but it is a mirror which is part of a hollow sphere. That is, the reflecting surface of the mirror is part of a hollow sphere. Okay, so these spherical mirrors are converted, okay, they are categorized into two parts. Okay, the first is concave mirror, the second is convex mirror. So what is a concave mirror? A concave mirror is nothing but a spherical mirror whose reflecting surface is always towards the center of the sphere. That is, let us consider a sphere. Okay, so this is a sphere. So what it means over for a concave mirror? Consider, okay, so concave mirror is nothing but whose reflecting surface it is always towards the center. This is the reflecting surface, this is the reflecting surface, and this is the polished surface. So in a concave mirror, the reflecting surface always it is towards the center. So this is the center. See, it is always towards the center of the sphere. So in case of convex mirror, the reflecting surface is always away from the center of the sphere. So this is a sphere. So the reflecting surface it is always away. This is the reflecting surface. Okay, this is the polished surface. So this is the center. Okay, so this is the convex mirror. So let us discuss some of the terms related to the spherical mirrors. Terms related to a spherical mirror. Terms related to spherical mirrors. Okay, so this is a hollow sphere. So what does the spherical mirror means? The reflecting surface or the mirror is always part of the hollow sphere. So let us consider any one of the mirror that we have known. That let us consider a concave, okay, let us consider a concave mirror. So this will be the reflecting surface away from the center of the sphere. So the first term which we will know here will be, so what is pole? The first thing is the pole. Pole is nothing but it is the midpoint. So this is the mirror. Let us name this as A and B. This part is mirror, right? So the middle point of the mirror is called as the pole and it is represented by P. So this is pole, that is the midpoint of the mirror. So second is center of curvature. So what is center of curvature and where does it lies? The center C of the sphere of which the mirror is the part. Okay, we know the mirror is part of the sphere. This is the center C. So this center is called the center of curvature and it is denoted by C. The third is radius of curvature. Radius of curvature. Okay, the radius of curvature, what the distance, it is nothing but the distance between the center of curvature, that is denoted by C, and the pole P. The distance between this is called the radius of curvature and it is denoted by R. So the fourth term will be aperture. Now what does this aperture mean? Aperture is nothing but it is the total diameter of the mirror. Okay, this part A, B, the total diameter of this reflecting surface, it is called the aperture. The length, the diameter of AB. Okay, so this is called the aperture. The fifth term is principal axis. Principal axis is nothing but it is a line. Okay, concentrate over here. Principal axis, it is the line that is connecting the center of curvature pole when it is extended. So whenever we extend the line between the center of curvature and the pole, okay, so this line is called principal axis. Okay, now the sixth term is principal focus, or just we can tell it as just focus. So what does this focus mean? Focus, it is denoted by F, small f. Okay, so what does this focus mean? Whenever the rays, okay, any parallel rays parallel to the principal axis, whenever a ray parallel to the principal axis strikes the mirror, they always meet at a point, or they appear to meet at a point. That point is called focus or principal focus. Okay, it is always in between the center of curvature and pole. This is, if this is the center of curvature, this is the pole. In the middle lies the focus. So it is also known that the one thing also it is, focus is always radius by 2, that is it is half of the radius of curvature. Focus is always half of the radius of curvature. So the next term will be seventh term, focal length. Focal length is nothing but it is the distance from the principal, that is the pole, to the focus, the point of focus. The distance between this is called focus, that is denoted by F. Okay, again important thing to be noted down is focus of a concave mirror. Okay, focus of concave mirror is always real. Point to be noted down, focus of concave mirror is always real, and focus of convex mirror is always virtual. Okay, these are the two important points to be noted down of focus. And the important points to be noted down about the focal length is, focal length is always independent of the medium. It is independent of medium. please note down these points because these are necessary for the competitive exams. Okay, focal length is independent of medium. And the next thing is, if a spherical mirror, that is when we know that it is independent of a medium, what does that mean? Whenever the mirror, it is placed, either it may be in air, it may be in any other medium like water or any other medium, it does not change its focal length. Okay, the focal length will be always unchanged, that is it remains same. Okay, so again, important point to be noted down about the focal length when we have studied about the plane mirrors. The focal length, okay, focal length, we know in spherical mirrors focal length is always r/2, but in focal length of plane mirrors is infinity. Okay, focal length of the plane mirrors is infinity. Point to be noted down. So these are the important things you should note down for the competitive exam sake. Okay, so these are all the important terms related to the spherical mirrors. So now let us discuss about the sign conventions, that is sign conventions. So to understand, to derive any of the formula related to the spherical mirrors, we need to understand how to calculate the distances in this mirrors. Okay, related to this, so first we will learn what sign conventions and how does it affect the measurements. Okay, so consider, so this is the concave mirror, this is the convex mirror, concave, and it is convex. So this is the pole P, the center part of the mirror. This is the principal axis. Okay, this is the principal axis. This is the center C. This is the focus F. Okay, in a concave mirror, the focus, the center of curvature always lies in front of the mirror. This is the front side, right? Front side of the mirror. In case of concave mirrors, the focus and the center of curvature, this lies in the front side of the mirror. But in case of convex mirror, the focus and the center of curvature, it lies behind the mirror, behind the mirror. So this is the back side of the mirror, this is the front side of the mirror. Okay, so we will know sign conventions considering these points, that is where does the focus and the center of curvature lies in case of concave mirror and in case of convex mirror. So the first rule for the sign convention is all the distances measured in the direction of the incident rays are positive. Okay, all the distances that are measured in the direction of the incident rays are positive. What does that mean? Consider a ray, okay, passing. So all the directions, all the measurements that we take from in this direction are always considered positive. So this is the first rule. And the second rule, what does that tells is all the measurements or the distances okay, are done from the pole. So how do we calculate the distances? In case of these mirrors, it is always considered from the pole. Okay, in case of concave mirrors, these are in this direction. We measure in this direction. In case of convex, we measure, okay, in this direction. From the pole, we measure in this direction. Okay, so this is the point. The third point is the heights, okay, above the principal axis are considered positive, and below the principal axis are considered negative. Now what does this mean? So this is the principal axis, this is the principal axis. So above this are considered as positive, below this as considered negative. Okay, so these are the three rules that you should know for the sign conventions. So now let us see what focus and center of curvature will be in case of concave and convex mirror. Okay, so in case of concave mirror, the incident rays are, okay, this is the front side of the mirror, so light rays will be in this direction, right? These are the light rays, and we make measurements from the pole. So this is in the opposite direction of the incident ray, so focus will be negative. So does the center of curvature. In case of convex mirror, light rays, this is the front side of the mirror, front side. So when light rays are incident, it is in this direction, okay, this direction. Also we do measure this measurements of focus and center of curvature from the pole. So in this direction, this is in the same direction of the incident ray, so focus will be positive, so does the center of curvature. Okay, so these are the things, that is sign conventions, these are the rules. Okay, so next we will discuss, okay, next we will discuss the rules for image formation. We have known the sign convention rules, now we will know the rules for image formations in spherical mirrors. So the first thing is, to get any type of ray diagram in case of spherical mirrors, there are some specific rays that are considered to form a ray diagram. So the first ray, okay, ray first. So what does this ray 1 mean? The ray 1 is a ray through the center of curvature, center of curvature. First ray is the ray through the center of curvature. Okay, consider two mirrors. This is convex mirror, this is concave mirror. Okay, so this is the C, so this is the C, right? So ray first will be the ray through the center of curvature. So the ray from the center of curvature is always deviated back in the same direction. Okay, so this is the first thing, the first ray. The ray from the center of curvature is always deviated back in the same direction. So this is concave, this is convex mirror. and the ray in case of convex mirror, the center of curvature ray, we can tell. Okay, so it appears, okay, it appears to be passing from the center of curvature. It appears to be passing from the center of curvature. It appears to be passing from the center of curvature. This is the first thing, the ray 1. So the second ray is ray 2. Okay, a ray parallel to the principal axis. Okay, a ray parallel to the principal axis. So consider this is the concave mirror, this is the convex mirror, concave mirror. You should actually know how these rays act, so that whenever you have any problems in MCQs, it will be easy to find where does the image form and what type of the mirror is used. Okay, if you know this image formations from these mirrors. Okay, so this is the P, this is the P, this is the principal axis, this is the C, this is F, this is principal axis, this is F, and this is C. So a ray parallel to the principal axis, it will be in this direction. This is the ray passing through the principal, parallel to the principal axis. So it passes through the focus. Okay, it always passes through the focus. Point to be remembered, parallel, whenever a ray is parallel to the principal axis, it passes through the focus. In case of convex mirror, whenever a ray parallel to the principal axis is struck at the surface, it appears to be passing from the focus. Okay, so this is a ray parallel to the principal axis. Now what is third type of ray? That is ray 3, a ray passing through the focus or principal focus. Consider concave, convex mirror, concave mirror, convex mirror, concave and convex. So what does this statement mean? This is the pole, this is the center of curvature, this is the focus, this is the principal axis, this is the focus, this is center of curvature. A ray passing through the focus. Whenever a ray is passed through the focus, it deviates back parallel to the principal axis. Okay, point to be remembered, whenever a ray passing through the focus, always it deviates parallel to the principal axis. This is the principal axis. Okay, so in case of convex mirror, whenever a ray appears, okay, to be, it is pointing towards the focus, it reflects back parallel to the principal axis. Okay, so this is the principal axis. Okay, so this is the third ray, that is the ray passing through the focus. Now fourth ray is and the last ray, a ray striking at pole P. So concave mirror, convex mirror, concave, convex, this is concave, and this is convex, this is principal axis, it is P, it is principal axis P, this is the principal axis and this is P. So whenever a ray striking at pole, okay, so this is C over here, whenever a ray strikes to the pole, it reflects back in the opposite direction. Point to be remembered, right? Whenever a ray is striking at pole P, it reflects back in the opposite direction. Same in the case of convex too. So these are the rays, 4 types of rays that we consider while drawing a ray diagram. So next thing, the next topic is mirror formula. So what does this mirror formula is? What is this mirror formula? The mirror formula is actually the relation between image distance, okay, object distance and focus. It is the relation between image distance, object distance and focus. Here the image distance is represented by V, object distance is represented by U and the focus is represented by F. So what does this mirror formula, what is this mirror formula, how it is derivated is not important, just remember the formula, right? So it's nothing but 1 by U plus 1 by V is equals to 1 by F. This is the mirror. There are many problems asked on this part of this ray optics, that is the mirror formula. You should be knowing this, okay? The next thing is magnification. Magnification. What does this magnification mean? It is nothing but the ratio of image. It is the ratio of image formed to the height, it's the ratio of height of image formed to the height of object, okay? That is nothing but the magnification of the mirror. The magnification of mirror is defined by the ratio of height of image formed to the height of object. So that is given by the formula. It is represented as M. It is height of image divided by height of object. Here we have taken it as the negative, that is minus V by U. So this is the magnification formula. The next thing we will note down, just a second. Okay, now the next thing we will be knowing is the image formations. Image formation by spherical mirrors, right? The first is image formed by concave mirrors. In case of concave mirror, the image is always erect, okay? Points to be remembered. the image is erect and virtual when object is placed between focus and the pole. Whenever an object is placed between the focus and the pole, the image is erect and virtual. And the second point is, in all other cases, the image is real and inverted, right? So we will be seeing the next 6 places of the image formations. Okay, the first is at infinity. When an object is placed at infinity, consider the concave mirror. This is pole P. This is the principal axis. Okay, this is the center of curvature. This is the focus F. Okay, so where does the image lie if the object is placed at infinity? At the infinity, we consider the parallel rays. Whenever an object is at infinity, we consider the parallel rays. Okay, so first we have studied the 4 types of the rays. Okay, so we'll consider here a ray passing from the focus. What do we know? Whenever a ray passes through the focus, it passes parallel to the, it reflects parallel to the principal axis. Okay, so the second is, we will consider a ray of from passing through the center of curvature. We know whenever a ray is passed from center of curvature, we have to be very peculiar when we draw this ray diagrams, because if we draw it correctly, we will get the exact place where the image is formed. Okay. Okay. So whenever a ray is passed from the center of curvature, we see that it passes back in the same direction. Okay. So at the interaction of the 2 rays, we will be seeing an image. So this is the interaction place, that is at F. So this is the image formed. So what do we know in this case? Whenever an object is placed at infinity, the image is real because it is in the front side of the mirror. Okay, it is inverted, right? And it is very small. Okay, you should be remembering these points by heart, so that in the entrance exams you can just answer it in a second, right? The image is real, inverted and very small, and it is placed at focus. Okay, it is placed at the focus. And what is the magnification? Magnification is much less than -1. What does that mean? The image is very small. Okay, the second point is, between, when an object is between infinity and center of curvature. Okay, so let us consider the mirror. This is the concave mirror. This is the polished surface. This is the reflecting surface. Okay. This is the principal axis. This is the pole. This is the pole P. This is the center of curvature C. This is F, focus. Okay, what we have told here, that it's between infinity and C, that is it is behind, object is behind C. Okay, it is, the infinity will be behind C and it's between the infinity and C. Okay, so this is the object place, this is the object O. Okay, now consider the rays. First ray, it will be passing parallel to the principal axis, right? The first ray, the ray parallel to the principal axis. Now where does this ray pass from? It passes from the focus, right? This ray passes from the focus. Now this is the first ray. Now the second ray, it passes from the center of curvature. Okay, center of curvature means it passes back in the same direction. Now the interaction between these two rays, where does they meet? It meets between the center of curvature and it is between the center of curvature and focus. So it is between the center of curvature and focus. It is the image formed over here. Okay, so what do we know here is, it is the image formed is real. Okay, it is inverted, it is in this direction, it is inverted and it is diminished. We can see the size. Okay, here the object is of this size and the image is of this size. It is diminished and between center of curvature and focus. Okay, and what does the magnification in this case? It is less than of -1. Now the third condition, that the third case is at center of curvature. Consider the mirror, concave mirror. This is the polished surface, the reflecting surface. Okay, this is the principal axis, this is the pole, this is the center of curvature, this is the focus, right? So we see here is the rays, first ray. So what is given here? The object is at C. So let us place the object at C. So this is the object at C. The first ray will be passing parallel to the principal axis. Whenever a ray is parallel to the principal axis, it passes through the focus, right? Now second ray is when it passes from the focus. Okay, what we see here is, whenever ray is passing through the focus, it passes back parallel to the principal axis. Okay, so the image formed here is, okay, there is some differences in calculation, otherwise we will get the exact image at C. Okay, so what we see in this cases is, the image formed is real, okay, inverted and of same size, okay, of object. It is of the same size of object and it is formed at the center of curvature. Here the magnification is equals to, that is nothing but -1. The next case is Fourth is when an object is between F and C. Okay, when the object is between F and C. So let us draw the mirror. Now we will see the principal axis. So this is the principal axis. This is the pole P. This is the center of curvature. This is the focus, right? So what is the condition given over here is between F and C. The object is between F and C. Okay, that is in the middle part of F and C. So the image is in this place, that is between center of curvature and between focus. So the first ray that passes is from parallel to the principal axis, it passes to the focus, right? And the second ray is passing from the focus and it passes back in the parallel to the principal axis. If we take the calculations, just a second, in a proper manner, we will see the exact diagram. Just let us draw it once again so that you should get the exact image. Okay, the exact place of image should be the same. So let us consider it properly. So this is the mirror. This is the principal axis. This is the principal axis. Okay, so this is the center part. This is the focus and this is P. Okay, the image should be at the same position. The object is placed between F and C. This is the object, and let us consider now the rays passing from this object. The first is parallel, it passes to the focus. The second is it passes to the focus and goes parallel. So the image that we get in this case is just behind the C. If you see here exactly, it's the exactly behind the C. Just we need to draw it properly so that you can get the proper image. Okay, this is the object and this is the image. So in this case, what we see here is the image formed is real, okay, inverted and large. Okay, it is large. Okay, because if we see the object and the image, we know the height is different in both this case. So here the image gets larger than the object, and it is between the this is infinity, right? It's between the infinity and the center of curvature. We can tell it is also 2f because half of this will be f, here it will be 2f. So it is between the infinity and to F. The next case is, fifth is at F, when the object is placed at F. Okay. Let us draw mirror. This is the principal axis. This is the principal pole. So this is the center of curvature. This will be the focus. When the object is placed at focus, we will see where the image will be formed. The first ray will be parallel. It passes through the focus. The second, it passes from the center of curvature. Okay. And it passes in the same direction backwards. Okay. What we see over here is the image does not form at the nearest distance, because the lines do not meet. They are the parallel lines. Okay. Here this concludes that the image is formed at infinity. Okay. Infinity, and it's real because it is not behind the mirror, and it's very large compared to the object. So what will be the magnification over here? It will be infinity. The magnification will be here infinity. Now the sixth is, when the object is between focus and principal pole. Okay. So let us draw the mirror. So this is the mirror. Principal axis, pole, center of curvature. This is the focus. When the object is placed between the focus and pole, the first will be the parallel, which passes from the focus. Okay, it passes from the focus. And the second one, the ray which is from the center of curvature. Okay, this appears to be coming because we just cannot see a ray passing through the object. So this ray just appears to be passing from the behind of the mirror. So here is the interaction over here. So in case of this, when the object is placed with the focus and the pole, we see the image formed is virtual because it is behind the mirror, erect. Okay, and it's in large size. When we compare the height, we can see here. Okay, it's in large size and behind the mirror. These are the 6 cases of the image formation case of concave mirror. So next we will see image formation in convex mirror. There are only 2 conditions over here. Okay, let us draw the mirror. This is the principal pole. It is convex mirror. So this is the reflecting surface, this is the polished surface. We see here the center of curvature and the focus is behind the mirror, right? Sorry, just a second. It's the center of curvature, and this is the focus, this is the center of curvature. Okay, firstly we see the object. The first case is when the object is at infinity. Okay, when the object is at infinity. So what does this mean? The rays coming are parallel. Okay, right? So these rays reflects back in such a way that it appears to be coming from the focus. So the image formed will be at focus. So what we conclude over here is the image formed is virtual because it's behind the mirror, right? And it's at focus. Okay, it is at focus. The second case is when the object is placed in front of the mirror. In front of the mirror. Okay, so wherever it may be, it just should be in front of the mirror. So this is the mirror. So this is the polished surface. This is the principal axis. This is the pole P. This is the center of curvature. This is the focus. So when, sorry, just a second. So this is the mirror. This is the principal axis, and this is the polished surface. This is the reflecting surface. This is the center of curvature. This is the focus. Whenever an image is placed in front of the mirror, consider this as the object O. So the first ray passing from here will be parallel. It appears to be passing from the focus. It appears to be passing from the focus. The second will be the ray that passes through the center of curvature. Okay, the ray that passes through the center of curvature. So this will be the ray. It appears to be passing from the center of curvature. It will be passing in the same direction since it is passing from the center of curvature. So the image formed here is virtual. The image formed over here is virtual. Okay, erect and diminished between P and F. You can see over here is the point of interaction is over here. So this is the image formed between P and F. So these are the conditions that is of reflection between the at the spherical surface of concave mirror and convex mirror. The last topic over here is power of a mirror. So what is this power of a mirror? Power of a mirror is nothing but it is the capability or the ability, okay, ability of a mirror to deviate the path of rays striking it. So how much does a mirror deviate the light rays? That is called the power of the mirror. That ability is called the power of a mirror. It is denoted by the formula P, which is equals to minus of 1 divided by focus, if consider it in meter. If we consider it in diopter, that is minus 100 divided by focus divided by, that is in meter, that is diopter D. So this is the power of mirror. In case of concave mirror, okay, and in case of convex mirror, in case of concave mirror, the power is always positive, and in case of convex mirror, it's always negative. Since we know focal length in case of concave mirror, f is always negative here, and here f is always positive. By applying the formula, that's P is equals to minus of 1 divided by f, we say here P is always positive, and in this case, in case of convex mirror, P is always negative. Okay, so these are the topics in the reflection of spherical image formation by spherical mirrors or reflection at spherical mirrors. Previously we have discussed the topic of reflection at plane mirrors. If you have not seen the previous video, just go in the link description below. In the next video, we will be seeing the refraction of light. Okay, so if you like the content of the video, please like, share and subscribe the channel Edusumit. Thank you for watching.